Hello friends, now come to the chapter limits and derivatives. Limits and derivatives. It is chapter number 12. It is a new chapter. Okay, and so now come to here in this chapter we will learn about what is limit, its representation, okay, then understanding limit with an example okay, then we will go to derivatives. What is derivative, its representation, okay, and understanding derivative with example. Okay, so these are the most, I can say, the important chapters of future. These limit and derivatives are also used in physics, in chemistry, in mechanics, and higher studies. Okay, higher studies. Okay, so we will use this. These are the most important. This is the most important chapter. So let's go limit first. Okay, what is limit and its representation? So limit means the study of change in value of function when there is a change of value in domain. Okay, change in the value of a function. We know relation and function. So let's say, let f of x is equal to x square plus 2x. So when value x changes to 1, f of 1, then it will become 1 square plus 2 into 1, which is equal to 3. Now when f of value changes to 2, it will become 2 square plus 2 into 2, that is equal to 4, 4, 8. Again, when f value changes to 1.2, what will be the value? That means it is 1.2 square plus 2 into 1.2, that will become 1.44 plus, it will become it will become 483.84. So when there is a change in value, in domain, then there is a change in the function value. Okay, there is a change in the function value. So when the value changes, So when the value of x changes, then this range also changes. Range changes. Okay. If x value changes slightly, if x plus delta x, when x value changes slightly, then accordingly there will be also change on the value of x in the range part. Okay, delta x. So this way of representation, this limit means whenever, suppose there is a range of values. Okay, suppose 0 1 0 1 2 3 minus 1 minus 2 minus 3 dot dot dot. So when x value changes from 0 to positive side, or x value changes from 0 to negative side, okay, negative side, whatever may be the change, whatever may be the change will automatically reflect on the result. Okay, so suppose we will say when x value changes from minus 3 towards 0, and again x value changes from 3 towards 0, so the value of f of x will give the required result. Okay, so this representation, so now how will we represent this? X tend to some value, let's say a may be a is a reference number. Okay, reference number. Okay, and so what does it mean? So limit is represented by this, and limit x tends to a. This means when x, suppose a is a number over here. Okay, suppose this is a number line. Okay, this is a number line, and here the value is a. When x tends to a, that means there are many more numbers before it and there are many numbers after a. Okay, if a is a natural number or any real number, there are numbers that are present before a and there are numbers a plus 1. Okay, let's say, what are those numbers? Okay, let's say this number may be a plus 1, this number may be a plus 2, and here the number may be a minus 1, a minus 2. So whatever may be the number, okay, whatever may be the number, when x value tends towards a, then f of x value will be nothing but it is directly replaced with the value this. Okay, so this is the representation of limit of f of x when x tends to a is equal to this. So this is the basic representation and there is nothing more in this. So now let's move to the derivative part. Okay, so now derivative, it is a type of limit. Okay, and it is represented by, it is written by, it is written as d. Okay, it is written as derivative derivative of x. Okay, so dy dx. Okay, so what is derivative and how it is written? Okay, so let f of x is a function, let f of x is a function x square plus 2x. Okay, so now dy dx of fx, okay, is written as limit x tends to so let f of x is equal to this. Okay, then the derivative of the function fx, okay, is represented by dy of dx of f of x, which is equal to limit of h tends to 0 f of x plus h minus fx by h, where limit exist. Okay, if limit doesn't exist, then we can't derive dy dx of fx. So for derivation, limit should exist. Okay, should exist. Now come to algebra of limits. Okay, what is algebra of limits, or we can say operations on limits? What are different operations we can do? So first one is sum of two limits, sum of two functions. Okay, sum of two functions, sum of two function, you can say limit of sum of two functions. Suppose f is a function, let f is a function and g is a function. So what is the limit of the sum of two functions? So limit of x tends to a of fx plus limit of x tends to a g of x can be written as limit of x tends to a within bracket f of x plus g of x. So this is the summation rule. Okay, this is the summation rule. Okay, now coming to limit of difference of functions. Let f of x is a function and g of x is a function, then limit of x tends to a f of x minus g of x is equal to limit of x tends to a f of x minus limit of x tends to a g of x. So this is rule number 2. Okay, so limit of difference of function, when the functions are within the bracket and the limit is given before it, then we can separate it. Okay, so there is no basic difference in this. Like summation, we write difference as well. Okay, now number 3, limit of product of functions. Let f of x is a function and g of x is a function. So limit of x tends to a f of x into gx can be written as limit of x tends to a f of x into limit x tends to a g of x. Okay. Now fourth, limit of quotient of two function, and denominator is not 0. Okay, so example, let f of x is a function and g of x is a function, then limit of x tends to a f of x by g of x can be written as limit of x tends to a f of x by limit x tends to a g of x, provided g of x is not equal to 0. Okay, g of x is not equal to 0. There is a theorem, okay, theorem that for any positive integer, okay, n, for any positive integer n, limit of x tends to a x of n by a of n by x minus a is equal to n a to the power n minus 1. So let us prove how this is possible. Okay, let us prove it. So now we have f of x is equal to x of n minus a to the power n by x minus a. Okay, now limit, so now if f of x is equal to this, then limit of x tends to a x of n minus a n by x minus a is equal to, so now let's check, when n is equal to 1, then x of 1 minus a of 1 by x minus a is equal to 1. X of 2 minus a of 2 by x minus a is equal to, can we write x plus a? Similarly, x of 3 minus a of 3 by x minus a, can we write x square plus ax plus a square? Can you write this? Now, when becomes 4, when n becomes 4, when n becomes 3, okay, when n becomes 2, can we write minus a? Can we write x cube plus x square a plus x a square plus a cube? Can we write this? This is a general formula, so we can write this, when n is equal to n, x to the power n minus a to the power n by x minus a is equal to x to the power n minus 1 plus x to the power n minus 2a plus dot 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 dot. At the end we will get a to the power n minus 1. Okay, n minus 1. So we can write x to the power n minus 1, so is equal to limit x tends to a n minus 1 plus x tend to x into n minus 2 x to the power n minus 2 a plus dot 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 plus a to the power n minus 2. Now when x becomes a, check out, and how many terms are there, check. When the power is 2, number of terms is 2. When power is 3, number of terms is 3. When power is n, number of terms is n. So here number of terms are is also n. So is equal to, when x tends to a, put the value of a in x. So it becomes a to the power n minus 1 plus, again this becomes a to the power n minus 1 plus dot 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 plus a to the power n minus 1. So it becomes n times. Okay, so the answer becomes n into a to the power n minus 1. So this is the result. Okay, so this is an important theorem, that limit of x tends to a, x to the power n minus a to the power n by x minus a is equal to n into a to the power n minus 1. So you have to memorize this. Okay, and there are also two important formulas are there. Limit of x tends to 0, when x tends to 0, sine of x by x is equal to 1. Number 2, when limit x tends to 0, 1 minus cos x by x is equal to 0. These are two important formula, just memorize it. Now come to algebra of derivatives. Algebra of derivatives. Okay. Number 1, dy dx of f of x plus g of x is equal to dy dx of fx plus dy dx of g of x. Number 2, plus or minus. Okay, whatever may be the, it will be same for plus and minus. Okay, now coming to the multiplication, dy dx of f of x into g of x is equal to dy dx of f of x into gx minus dy dx of g of x into f of x. It will be plus. Okay, it will be plus. Okay, now coming to the division part. D by dx of f of x by g of x is equal to d by dx of f of x into gx minus d by dx of g of x into f of x whole divided by g of x whole square. Okay, so this is the division part. So now we have come to an end of the chapter. We understood limits, we have understood derivatives, algebra of limits, algebra of derivatives. So its representation. Okay, and we have also learned certain theorems. Okay, theorems in limit. Okay, these are formulas, important formulas that we have learned. So this is all about limits and derivatives. So next we will go to the question and answer part, okay, in the next session. Thank you.